Okay, so let's recall what we learned in our previous class. So we're going to be writing an algorithm to calculate the area and the perimeter of a square, of a rectangle, sorry. So without any further wastage of our time, let's begin. We start again with the algorithm keyword, algorithm followed by the algorithm's name, area, and perimeter. Perimeter. Let's just leave the name short. Isn't it our algorithm? So we want to define our variables. Yes. Oh, I forgot to mention this, but there is no specific syntax for an algorithm. You just write it like that. There is no specific way to write an algorithm, but there are some popular ways to write an algorithm, which is what I'm showing you guys. And the whole idea behind algorithm is not even the syntax. The whole idea is your ability to think, and that is what I'm going to be teaching you guys. So let's continue with our video. So we want our variables. We want, first of all, something where we will store the area. We want something where we will store the perimeter. We want something where we would store the length, and we want where we would store the width. And these are all going to be of data type integers. Integer. Right? Now the next thing we want to do is we want to begin our algorithm. So let's just go ahead and begin. So we want to prompt the user to enter the length, enter the length and width. We're going to read this length and the width into these variables. Then later on we are going to assign it. Now once we have the length and the width, we know that the area, so we use now the assignment operator, and in the last video we didn't use this operator, so I just wanted to create one. So it's going to equal to the length times the width, right? And the perimeter is going to be equals to the length plus the width, or that times 2. So there, so now we can display this message, right? Okay, we can write the area is comma a, and then on that same line comma the perimeter is, let's just put this here to make it look classy, and b, and end of statement, and we end our algorithm. So here there's our second algorithm. Now we're going to be looking at, so initially I know we didn't talk about flowcharts, but flowchart is simply a pictorial representation of an algorithm, and I'm going to just be making this video. So we want to convert this algorithm or this pseudocode into a flowchart. So let's see what will happen. But before we start, we want to define the elements of a flowchart. So let me just turn the paper, and this is an oval. Don't mind the way I draw it. This is either the start or the stop. It is known as the terminal. So data must always start and end in the terminal. So that's the first thing you need to know about an algorithm. Now this shape right here, yes, I'm guessing you guessed the shape correctly because I drew the shape correctly, so I hope you guessed it correctly. Yes, it is the shape you're thinking of, a parallelogram. It signifies input or output in a flowchart. Then the next shape we are going to be looking at is this guy here. Yes, it's the diamond, and it signifies a decision. Then another guy we want to look at is this my paddy man. He signifies a process. So, well, let's not forget the most important, the arrows. These arrows they show the direction of data flow. They show the direction of data flow, and there's this one last small guy. This guy is a circle. This is an oval and this is a circle, and the circle signifies a connector. So okay, with that we want to convert our second algorithm. If you didn't see the first, go and watch the video, but it's no big of a deal. So let's flowchart. Let's write our flowchart. The flowchart of this algorithm or this pseudocode is this. So first things first, we want to start in our terminal. Start. Once we've started, direction of data flow, data is flowing downward. Input or output, what do we want inputted from the user, this and this. So input LW. Now once LW is inputted, we want to store it, right? And this is a process, the process of storing. So A is assigned to, and B is assigned to. Yeah, flowcharts don't need semicolons. Yes, you got it right. Now we want to output this data. And remember saying our data must always end in the terminal. Well, yeah, that's what we have for us for today. And yes, anyhow, so I hope the code is understood. I hope the flowchart is understood. And with this, we are going to move into control structures. So I'm just going to turn the paper. The control structure simply determines how data flows in an algorithm. So yeah, that's what control structures are. They are now there are types of control structure. We are going to see the serial or the sequential control structure, which is this. We see that all the codes get, or all the algorithm gets executed in a linear manner. Now that is the sequential control structure. So with the sequential control structure, the algorithm gets executed in a sequential manner. That's the first control structure we're going to be looking at. The second control structure is going to be the selection or the condition control structure. Selection or condition control structure. So the algorithm actually picks one. It picks a specific instruction in order to execute based on some predefined rules. So we're going to be looking at the general structure of general structure of a control structure. So let's just say it's a basic if statement. If then there's a certain condition here, if this condition turns out to be true, then something is happening, like a set of instructions are executed. So instruction execution. Else instruction execution. So the computer has like the right to like pick a certain set of instructions. If this condition turns out to be true, this should happen, and if it turns out to be false, this should happen. So that's just the basic structure of an if else statement. Well, this is a double alternative, so let's just call it double alternative. And well, a single alternative, I believe you can guess it, because it's quite obvious. A single alternative is simply a classy if statement, if condition, and then instruction execution. And we simply end the if. And we can also have, now let's take a look at their flowchart. So the flowchart of the control structure looks something like this. So we want to start our data in the terminal, the start, or you could use, so we want to, like, I don't know, get some series of inputs depending on you, or a process. So assign something, let's just put process. This isn't really important. What is important here is the decision making factor. And we remember from the previous video that decisions, okay, that doesn't look like a diamond, but for my defense, okay, I have nothing to say for my defense. So you just put the condition, and looks something like this. This is for a double alternative, so actually it has double alternatives. And well, something like this, condition 1 and condition 2, and we could always connect them with our old friend the connector, and we put this data in the terminal. So well, that's how the general structure looks like. So why don't we do an application, because truly learning without applying is kind of useless. So we want to determine if a number is positive or the number is not positive. Well, if a number is not positive, then it is 0. So before writing an algorithm, you need to think, what exactly do you want to do? So if the number is greater than 0, that is what you want to do, then it is positive. And if the number is less than 0, then this number is negative. So that's what we are trying to do here. So that is what we need to tell the computer. Let's call it positive checker. I don't know, you could always call it how you want, but just don't let a space amongst them. So we want our variable, and the variable is going to be the number the user enters. So it's going to be an integer. Sorry about that. And we want to begin our algorithm. We will ask the user, as usual, enter a number to check well, let's read this number. We'll store it inside the variable num. Now we want to use now our control structure to check if a condition is true. If it is, then a particular instruction should happen. Else, if it is not true, then it shouldn't happen. So if num is greater than or equals to 0, then write the number imputed. The number imputed is positive, right? Because everything greater than 0 is positive. Else, So if you're looking closely, you would see that my else and my if are not aligned, right? So there's some sort of like line here, and yes, that is how it's written in algorithms. Else write the number imputed is negative. So yeah, that's the algorithm, and we want to end our if statement and we want to end our algorithm. So if you see here, this kind of aligns up and this lines up as well, and there is our algorithm. So in essence, what this algorithm does is it asks the user, using a right line operation, asks the users to enter a number. Once this number is entered, it's being stored in a memory location we designed, and we use a control structure to check a particular condition. If this number is greater than 0, then this happens, else this happens. If it is not, else is like if it is not, right? So yeah, else is the default condition. So if the if condition fails, the else condition automatically is executed, and that's true. A number can either be positive or negative, except for complex numbers because math students. But anyhow, let's limit ourselves to real numbers. So okay, let's go with the flowchart. So we want to start once more time in our terminal. We would start, and the next thing we want to do is we want to get the number from the user. Input num. Now a decision is being made, right? Is num greater than or equals to 0? Question mark. Yeah, my triangle is not big enough so you can't really see it, but in essence that is what is happening here. First condition is it's an output, right? Is num greater than or equals to 0? Yes. If the condition turns out to be true, we want to output num inside string is positive. Okay, yes, my drawings are really small and I'm going to make this one better. Just watch me make it better. So okay, we want to output num is negative. This is the case of a no. And well, with our old friend the connector, okay, I feel like he's too big here, but anyhow, at least he's still a circular, not a terminal, and we want to end. Yeah, I forgot that. So yeah, that's how. There it is. So the next thing we want to look at is, well, we saw the syntax of a double alternative. So that of a single alternative looks like this. I don't know, maybe there's a process here, whatever. And now in the case of a decision, since it is a single alternative, there is like just something here, there is a particular condition and there is a process, whatever, I don't know, and it continues down here, and whatsoever gets out like this. If it's a process, well, whatever it is, and then data ends in the terminal. So this is how the syntax of a single alternative looks like, because what I showed you guys last time, the syntax last time was that of a double alternative. This is a double alternative and this is what a single alternative looks like. And yeah, so we're going to be looking at, so we also have the multi-alternative, like the multiple alternatives. The multiple alternatives is simply like multiple if else statements, like if else, if else, if else, if else, and that's so like it's like if condition, then instruction execution, else if condition. So multi alternative, like it has like multiple conditions, so you need to check if all these conditions are true. So that's kind of the thing here, hence the name multi alternative. Else if another condition execution, then instruction execution, and let's just end it there. So else instruction execution, and right here we want to end our if. So that's how the multi structure looks like, and it's okay. I feel like it wouldn't enter here. Yeah, it wouldn't enter there, so let's just turn it over, and it looks something like this. The terminal start, and the condition keeps going. Well, why don't we just write a program to illustrate this instead of wasting our energy with the general syntax? So let's create, I don't know, a program that counts the number of days. So if the user enters Monday, it tells us the day is Monday. User enters Tuesday, it tells us the day is Tuesday, and the user enters Wednesday. So like that kind of. Well, we're going to write the pseudocode, that's the algorithm, and we are going to draw the flowchart. What do you guys think of it? So without any wastage of time, let us begin. So the first thing we want to do is have a very clear idea of what we are to design. So one thing we want to do is we will need one variable. This one variable is going to hold the data the user will enter, and we're going to check for multi conditions. The essence in writing an algorithm, as I earlier said, is to know exactly what you want to write before writing it. Like you can't go on writing an algorithm with no specific ideas. So now that we have a clear idea of what we want to write, let's start writing. Yep, days of the week. Now we have just one variable and it's an integer. I feel like we are only using integers, but anyhow, let's call it day integer. So let's begin our algorithm. Right, we want to take the day of the week from the user, enter a number to know the day. Let's put this in here. We want to store this number inside. Sorry about that. Inside D. I lost a little bit of focus, but no worries. The next thing we want to do is we want to check if day equals to 1, then we want to print a message, right? It is Monday, unless the first day of the week for you is Sunday, then you write it is Sunday, but for me it is Monday, so I'm just going to write it is Monday. Now else if day equal to, then write it is Tuesday. Then else if again. So yeah, that's the essence. So I'm going to forward the video a little bit. Cos 3 and else write the number, okay, is not a day of the week. So this is just like maybe the user tries to enter 8 or something. So if it is not amongst the range 1 to 7, then it is not a day of the week unless your week has more than 7 days. But mine don't, so my algorithm would just do that. And we want to end the if statement. And if so, yeah, let's end our syntax. So yeah, this is a code of how the multi if statement looks like. So we see that it has this sort of diagonal pattern, and wait until you see its flowchart. Okay, let's get down to writing its flowchart. So we could always use the pseudocode to get the flowchart. Pseudocode flowchart. So let's get going. So the first one, now we want to get the input, right? We want to get the number of days. So we will ask the user to input days. Ask user to input days. Now we get our very first. I feel like I drew it too big, but is days equal to 1 question mark. So this is the yes. So if there is a yes, then we have an output. Output, it's Monday. Right? We want to output it's Monday. Well, later on we'll take that and store it in the connector. No. What will happen if it is no? Then we want another decision. Is this equal to 2 question mark? If yes, we have an output. Okay, I feel like this output kind of like interrupt with this other one, but no worries. We get another output. It's Tuesday. No. Then we get a decision. Is this, so I believe, sorry, the variable is day. So is day, not this. Let's take away the s there. Is day equals to 3. So I believe at this point you kind of like get the general syntax. All of this will later on be connected to a connector down here. So I'm going to skip to the end of the video where you would see the final flowchart. Okay, so we just want to connect all of these, connect them like this. To a single line of output which outputs to the terminal. Sorry about that. And we want to put a connector here. And yeah, that's the flowchart for this. Don't forget your arrows, flow of data. And yes, no, yes, no, yes, no. And don't forget the question marks here as well. So you all have question marks, as you can clearly see. Well, this is going to be the end of this tutorial. I hope you all learned something and I hope you enjoy it. Please like and subscribe.